Scaling autonomous enterprise AI depends on the rigid infrastructure built to secure it, rather than the reasoning limits of the models themselves. For an AI agent to execute meaningful work, it requires read and write access to production environments. This means granting the agent real credentials for services like GitHub, Salesforce, and Stripe. This is an LLM's context window, its active working memory, ingesting structured commands and unstructured data. Traditional architectures pass WA API credentials directly into this space. Because this token sits here, every character is exposed to the model's text processing mechanisms. Exposing raw authentication tokens directly to the reasoning engine creates a structural vulnerability. It provides direct API access to a processor that takes instructions from potentially hostile external sources. This exposure enables prompt injection, the practice of hiding malicious instructions inside the unstructured data the agent is designed to process, such as an email body or a poisoned API response. Hostile instructions command the model to override its intended behavior. The model isolates the credential in active memory, wraps it into a payload, and executes an unauthorized HTTP post request, exfiltrating the raw token to an attacker-controlled server. Security policies and system prompts fail here. Once injected instructions enter the processing stream, they can override the model's baseline behavioral guidelines entirely. A common misconception in enterprise security is that encrypting these tokens with AES 256 solves the vulnerability. Encryption fails because the decryption key must share the same process space to execute the API call. An attacker capable of extracting the ciphertext can extract the key right alongside it. Protecting credentials through instructions is security by policy. Securing the system requires security by architecture, physically separating the credentials from the reasoning engine. True enterprise security requires an architecture where the attack vector is completely eliminated. To achieve this, the LLM must never hold the credential in any form. Heartbeat Agents eliminates this risk through the credential broker. This pattern enforces a physical separation between the agent's intent to perform an action and the platform's mechanism for executing it. The process begins with registration, which is triggered the moment an agent requests access to an external system. This diagram displays two isolated environments. The broker decrypts the true token into an isolated memory segment. It then generates an opaque handle, a random 24-byte string, and maps it to the token inside a private dictionary. This handle crosses into the agent context. This string is not a hash. It contains zero mathematical relationship to the real credential. The handle is ephemeral. It has a strict 300-second time to live and is completely invalid outside of this specific running process. Because this dictionary mapping lives only in volatile memory, the relationship between the handle and the token never touches Redis, local disks, or external databases. If a prompt injection successfully extracts data from the model, the attacker receives a meaningless, rapidly expiring pointer that cannot be reverse engineered or used externally. The agent now moves to the execution phase, attempting the API call through its assigned tools. The agent initiates an HTTP request. For authentication, it provides only the 24-byte opaque handle. This visualization illustrates the intercept. The platform OS halts the request, looks up the opaque handle in its isolated dictionary, and injects the actual token into the authorization header. The platform maintains static integration definitions for hundreds of services. These dictate exactly how the authentication injection happens, removing control from the agent. The system also utilizes auth collision detection. If a compromised agent attempts to forge its own authentication headers alongside the handle, the broker detects the collision and instantly terminates the connection. The OAuth token exists in memory only for the millisecond duration of the outbound HTTP call. The moment the call completes, the token is scrubbed. By separating the API call's intent from the authentication mechanism, the agent is physically stripped of the ability to view or leak the actual credential. The credential broker operates on a foundation of explicit capability assignment. Every request requires an agent integration record, a mandatory database entry that explicitly maps a specific agent to a specific external tool. This logic schematic illustrates the architecture. If the exact database pairing does not exist, the platform defaults to a fail-closed state. Access is automatically denied. This rigid binding prevents lateral movement. If an attacker breaches one agent, they have no path to the integrations assigned to another. There are no administrative overrides or fallback permissions accessible to the model. Access control is hard-coded into the immutable data layer, removing the possibility of logical bypasses by a compromised agent. The broker pattern is one layer in a defense-in-depth architecture, a multi-boundary system built on the assumption that every internal layer will eventually be breached. Consider a worst-case scenario. A novel prompt injection compromises the reasoning engine and attempts an outbound post to an external server. This diagram tracks the outbound payload hitting the egress policy, a rigid checkpoint dropping traffic not bound for an approved host. As the connection initiates, the DNS rebinding defense locks the target IP address at the precise millisecond, preventing routing exploits. Finally, the traffic hits the egress container network. A squid proxy sits on the perimeter, categorically blocking all unauthorized container traffic and private IPs. Even if the agent is commanded to exfiltrate DAED, the surrounding network topology is physically configured to block unauthorized destinations. Boundary 5 deploys the token scrubber, executing 11 parallel regex patterns across all output streams to catch residual anomalies before they reach the user. This shows the final boundary, strict Docker isolation. Every execution runs inside an unprivileged container that drops all capabilities and mounts a read-only file system. Each of these 7 layers operates independently.
A failure in one does not compromise the sequence. Most AI platforms rely on instructions or single-layer encryption keys. They give the model the data and ask it to behave. Enterprise AI scales only when infrastructure dictates security, physically preventing the model from executing dangerous behaviors. Heartbeat Agents operates as a foundational operating system for autonomous agents. It provides the ultimate structural guarantee. You cannot steal what the agent never possessed.